Have you ever played a really tense game of Jenga? As the tower gets taller, every single piece you touch threatens to bring the whole thing crashing down. That is exactly how many massive critical computer systems have been built over the last 30 years. In the software world, we call this a monolithic system. You see this a lot in healthcare, where massive legacy applications, like the popular claims processing system called QNXT, run the entire business. This graphic shows how a monolith is constructed. Everything, patient records, billing, scheduling, and claims, is baked together into one solid block. All of those different interlocking gears are forced to share a single giant bucket of data at the bottom. The problem starts when a company needs to make a small update. Say they want to add a tiny new feature to the billing process. Because everything is so tightly locked together, touching that one billing gear causes all the surrounding gears to grind and lock up. To actually install that tiny update safely, engineers have to take the entire system offline. They update the massive program all at once and then power it back on, crossing their fingers that it works. And if there's even a minor typo in the new billing code, the whole block fails. The entire system crashes, bringing vital services like patient claim processing to a complete halt. As long as a company's vital infrastructure is built as a single tangled block, they are stuck moving at a snail's pace. Every new feature carries the constant fear of a total system collapse. Now, imagine we throw away that fragile, heavy block. Instead, we build our digital city out of independent, specialized toy bricks. This approach is called a microservices architecture. It's the modern software equivalent of building with Legos. We break that giant monolith apart into separate, independent blocks for billing, claims, and scheduling. Each block gets its own private data bucket. Because this data is partitioned, a security flaw in one block doesn't give an intruder keys to the entire city. With the software broken into pieces, how do they communicate without tangling? They use APIs, or application programming interfaces. APIs act as strict rules for connecting, like the bumps and grooves on toy bricks. They click securely, pass information, and unclick. By using these strict API connections, every piece of the software can operate entirely on its own. They share only the exact packets of information needed to run the business, and nothing more. Let's look at how this modular design actually behaves during a real-world crisis compared to the old Jenga tower. If a bug takes the billing block offline, the fault is isolated. Claims and scheduling ignore the broken piece and keep humming along. The system doesn't crash. But what about a sudden traffic spike? Say flu season overwhelms the scheduling block with appointments. Instead of copying an entire massive system to handle extra load, engineers simply add the specific block they need. Snapping extra scheduling blocks into place instantly divides the traffic jam into manageable streams, all without touching the rest of the software. Companies now have the power to fix isolated problems and scale their capacity on the fly without ever having to pull the plug on users. Looking at the two side by side, the contrast is clear. On the left, a tangled, heavy monolith. On the right, a neat, breathing grid of independent microservices. Moving away from that monolithic trap has real-world impact. For insurance providers, adopting this modular approach has accelerated the processing of medical claims, making them up to 3 times faster. And this diagram shows how modern microservices can even act as a bridge to those older systems. Here, an independent invoice service connects cleanly via an API to safely pull employee data straight from the old monolith without risking the older system's stability. For you and me, this translates directly to better data security, faster load times, and the end of those annoying scheduled maintenance lockouts. The complex technology behind our modern digital lives is finally becoming as flexible as we need it to be. So the next time your favorite app updates instantly without crashing, you'll know their secret. They stopped playing Jenga, and they started building with Legos.